Hello everyone! Welcome to our physics class where we're going to learn physics in a very simple way. This grading, we're going to learn about motion in one dimension. Motion happens every day, from the very simple activity like walking, running, and other things that we do every day, to the forms of motion that happen inside our bodies, and even the rotation and revolution of our planet Earth, and the many examples of motion. Indeed, we can say that motion happens every day. This is a branch of physics that is called kinematics, the study that deals with the description of motion. And here we classify motion as linear and curvilinear. Linear motion is further subclassified into horizontal motion, which we're going to focus here in grade 7, and vertical or free fall, which we will cover in grade 9. And curvilinear is specifically what we call the projectile motion that will be learned in grade 9. Let's define motion. Motion is defined as a continuous change in position with respect to a fixed point or relative to a given reference point. Well, motion is said to be relative. What does that mean? That means that we describe motion from a reference point. A reference point is defined as a starting point or origin for measuring motion. It's just like looking at this picture at the right, where it depends on your perspective. You can focus on the black part of this picture or the other part of the picture, and depending on what you focus or your perspective, you can see some things that are quite different. Okay, furthermore, I have here an example. This is an example of Barry, who is on the left side of the sink in the diagram, in the first image that you can see here. And let's consider the sink as the reference point. Now look at the second picture or diagram. Barry has begun moving, but the sink stays in the same place. And so we can say that Barry changed his position and that he moved from one side of the sink to the other. And on the third picture or diagram, you can see that Barry has made across the room, and you can tell because there are reference points that stay in the same place and don't move. In this chapter, we're going to describe motion using what we call descriptors of motion, which are physics terms that we will be using throughout this chapter. Let's enumerate them. First is distance. What do you think is the other one? We have displacement, average speed, average velocity, and acceleration. There are two types of physical quantities. They are scalar quantities and vector quantities. They're both types of quantities, but scalar quantities only refer to the magnitude of the quantity, of the physical quantity, magnitude or the amount or the size of that quantity, while vector quantities refer to the magnitude and the direction of the physical quantity. The first descriptor of motion is distance. It's symbolized by small letter d. It's defined as the total length of the path traveled by a moving object regardless of its direction. Its System International or SI unit of measure is meter, symbolized by small letter m. It is classified as scalar quantity, meaning it only describes the magnitude of the length traveled by a moving object. Example is 100 meters. The second descriptor of motion is what we call displacement. Its symbol is small letter d with an arrow on top of it. It is defined as the object's change in position going to a particular direction. Its SI unit of measure is meter, and it is classified as a vector quantity, meaning aside from the magnitude, it specifies the direction. And that is also the reason why there is an arrow on top of its symbol. An example is 100 meters east. The third descriptor of motion is average speed. Its symbol is small letter v with a subscript AVG for average. It tells how fast or how slow an object is moving, and it is mathematically defined as the total distance traveled by an object in a certain amount of time. The SI units of measure for average speed are meter per second and kilometer per hour. It is a scalar quantity, so no direction is involved. Examples are 10 meters per second and 100 kilometers per hour. The fourth descriptor of motion is average velocity, symbolized by small letter v with a subscript AVG and with an arrow on top of it. It tells how fast an object is moving and the direction where the object is going. It is defined as the total displacement of an object in a certain amount of time. The SI units are the same as that of average speed, meter per second and kilometer per hour. It is classified as a vector quantity because it tells us the direction aside from how fast the object is moving. Examples are 10 meters per second north and 100 kilometers per hour south. Finally, the fifth descriptor of motion is what we call acceleration. It is symbolized by small letter a. It is defined as the rate of change of velocity. SI units are meter per second squared or m over s squared and kilometer per hour per second. And it is classified as a vector quantity because it has a direction along with the magnitude of the acceleration. Example is 3 meter per second squared north. Okay, looking at it in this diagram, acceleration is the rate of change in velocity, and in symbols, you can see there triangle V divided by triangle T. Triangle is a Greek letter delta, which means change, or it symbolizes change. That's why it is triangle V over triangle T, or change in velocity over change in time. And acceleration is actually achieved, or it is done by speeding up, by slowing down, and by changing direction. Summarize everything in this table. You can see all of the descriptors of motion the type of quantity, symbol, formula, the units of measure, and example for each of the 5 descriptors of motion that we have covered. And that is all for today. Thank you for watching.